Hey guys, good morning, all of you.
Good
Can you hear
morning.
me?
Yeah,
Hi,
yes, sir.
good morning.
Yes, yes.
Yep.
Morning, sir.
Good. So guys, already we have done with almost all the BGP concept like BGP split file, route reflector, full maze. Then after in the route reflector, we have seen the originator ID and the cluster ID concept, right? And also we went through that configuration part, and also we have seen the next hop self command. What is the use of that next hop self command? Then we went through that dynamic membership. That's a amazing feature of the BGP and the peer group of IBGP and EBGP. Right now, the next thing is that try to understand one thing, and this is the most important topic for the BGP, and this 100% this topic is coming for any interview, not for the any interview. Without this topic, you cannot pass your CC exam even, right? This topic is so much important. Now try to understand. Tell me one thing. Right now, what happened? We have router number one, router number two, three, and four, right? And what happened if I'm going to run the RIP protocol of it? If I'm going to run the RIP protocol, I want to make this guy as a primary. This path should be primary and this path should be secondary, right? How do I make it? In a RIP, if I'm going to advertise all this route, right? Try to understand, if I'm going to advertise all this route in the RIP protocol, and I want to make R2 should be a primary, it means that when this user, right? When this user will send any traffic, when this user will send any traffic to this subnet, right? 4.0, 44.0, it always go by the router number 2, always, because this is my primary path. So if I'm going to run the RIP protocol, in that case, what happened? We can use the hook con to manipulate the, right? If I'm going to use the RIP protocol over there, so in this RIP, what happened? We have a hook con to manipulate the path, right? What happened if I'm going to use the EHRP?
Delay concept.
Yep, delay, or either you can go for the bandwidth,
100 off offset list.
either you can go for the offset list as well, right? Or either you can go for the AD value as well. You can manipulate through the AD value as well, right? What happens if I'm going to use the OS cost? Yeah, you can use the cost to manipulate the path. Even based on the summarization, you can also manipulate the path, right? So can you see that basically what happened in every IGP routing protocol, right? Doesn't matter if you go for the RIP, EHRP, and OSPF. Doesn't matter if you go for the RIP, EHRP, and OSPF. You basically you have a one and two max to max, because AD is not recommendation to use many times to manipulate the path. Not recommendation, right? If I'm going to use the RIP, I just have one. If I'm going to use the OSPF, I just have one. If you go for the EHRP, you must max to max, you have a delay and bandwidth. You can use the option list. But you know one thing, as I told you that the BGP routing protocol, BGP is the backbone of internet. It's a backbone, right? Without BGP, the complete internet will be never run, never run. Because it's the only routing protocol that is going to maintain the millions of the route. And in internet side, what happened? As I told you, this is the backbone of internet. On the internet side, what happened? From one source to another destination, right? On the internet, what happened? From one source to another destination, we have a multiple. From one source to one destination, we have ultimate multiple path we have. So can you imagine? Can you imagine if I'm just going to use the rib? How many ways I can manipulate the path? Just a single way. If I'm going to use the EHRP, you can go for the 3 and 4 ways, right? If I'm going to use the OSOP, you can just with the cost over there. If you just have a look over there, in interrupt rate, can you see? Not this one. I'll go for some different. Yep. Or you can go for this one. This is a good one. Save the better way. And the picture. This one is also good, right? Can you see? This is the normal internet picture. In this internet picture, what happened? Just have a look at the one source, right? This is the one source. From one source to one destination, how many paths we have? I can go via, I can go via like this, right? I can go via like this. I can also go via, right? I can also go via like this. I can also go via like this. And I can also go via like this, or I can also go via like this. From one source to one destination, we have a huge number of paths. And in that case, if I'm going to use this protocol, right, this is the one of the another advantage. I'm just trying to explain this is the one of the another advantage of the BGP over the IGP protocol. This is the one of the another advantage of BGP protocol over the IGP. If I'm going to use this protocol, right? If I'm going to use this protocol is not so much scalable. This protocol is not so much scalable to manipulate the path on the internet side because they just have 1 and 2 ways. Whereas in the BGP, as I told you, it's a backbone of the internet, and from one source to another destination, we have a multiple path. And this is a routing, this is the only routing protocol that is going to maintain the millions of the route, right? So as compared to IGP routing protocol to BGP, we have a huge amount of path attributes. We have a huge amount of path attributes to manipulate the path on our internet side. If you're just going to use a BGP, in a BGP, almost we have a 11 ways to manipulate the path. Almost 10 to 11 ways we have manipulated just for the CCNP level. Right? If you go for the CCI level, we have a one and two more things like a cost communities comes in the picture, right? You can so it's totally depend on the requirement, right? So mostly we have 11 ways. Even in the exact in an interview, what happened? Mostly you are going to tell the 11 ways, right? But if you go for the CCI levels, right? If you go for the much and much detail level, what happened? Depend on the requirement. Things are coming in the different ways. Like mainly what happened if you go for the EHRP, we have a delay and bandwidth, right? But if you go for the more detail, you can manipulate the path based on the ID. And if you go for the much and much detail, you can manipulate the path based on the summarization, right? Longest prefix match. Same thing. Mostly what happened in the BGP, we have path attributes, and based on that path attribute, we can manipulate the path in BGP. And almost we have 11 ways. And as I told you that what is path attribute, if you remember that path attributes is nothing but it's just extra information about the route. Whenever whenever BGP router advertise some information in the sense of what I'm talking about the route information. They put that information in the BGP update packet. But at the same time, what happened? particular route. We have seen, if you remember that, we have seen some types of extra information like a AS path. We have seen extra information like a next hop. So seeing like we have some extra information about the particular route. So this information, this extra information is known as a path attributes, or we can say BGP attributes. And based on this attribute, select which one is the best. Second best. For example, try to understand when this router, right, router number one, when this router is receiving a one route, 1.0.0.0.0.0.0, I'm talking about the OSP perspective, right? And if this guy is receiving this route with the cost number 10, right? This is the cost is 10. At the same time, what happened? Router number one also receiving a one route, same route, 1.0.0.0.0. The cost is what? 20. So in this case, what happened? Router always maintain the best path information, right? Router always maintain the best path information. So in this case, what happened? They will say that, okay, I'm going to maintain this route in the routing table, 1.0.0.0, cost 10. I'm going to learn this information 0/0. This will become the second best, and this will become the best path, right? Same thing in BGP, what happened? When I'm going to define the best and second best path, right? I'm going to define based on the attributes. And this attributes always seen in the BGP update packet, always. In the BGP update packet, this attributes are present, and this attributes is nothing but just extra information about the particular route. For example, AS path. For example, extra information. These are the attributes, right? So whenever the router is sending the information, whenever the BGP router is sending the this update packet, in this update packet, they are just putting the extra information. If you remember, we have three fields in the update packet. One, we have a withdrawn routes. Second, we have a path attributes, and third, we have a NRI information. So we have three information are present in the update packet. This is the extra information. This is the extra information of this particular. For example, this is NRI. In this NRI, we have a 1.0.0/8 information, right? Network layer utility information, prefix and prefix length. So this will become the prefix, right? This will become the prefix, and this will become the prefix length, right? So about this particular route, we have some extra information. That extra information is known as a path attributes. And how many path attributes we have? We have the first, we have wait. Then we have a local preference. Then we have a self-originated. Then we have a origin ACE path. Then we have a origin code. Then we have a MED, metric exit discriminator. That's also a metric of the BGP. We can say that BGP AD value. Space, right? Right. Then we have a IGP cost, lower IGP cost. We can say that. Then we have a EBGP pairing. In normal language, we can say that oldest path. And then we have a lower neighbor router ID. Then you have lower neighbor IP address. So can you see we have a one, two, three. So first weight, it's also going to be to the higher weight is more LP. Local preference is also known as LP, right? Higher LP is more preferred. Then we have a lower east path, right? Copy. Then origin code MET also lower. MET is you can say that it's a BGP matrix, right? It's a BGP matrix. We have three types of origin code, right? The first we have IGP, that is going to represent that I, right? Then we have our second is EGP, that's going to represent by E, and third we have incomplete, that's going to represent by the question. I'll explain you each and everything, don't worry. Okay. So one we have IGP, right? Like different color red. Second we have a EGP, that's going to represent by the E flag. This is the flags, all right. And third we have incomplete, that is going to represent by the question mark, right? So three origin code we have. Okay. Then third we have MET means lower MET is preferred, right? BGP means what? Lower, like we can see that in a normal language, eBGP over iBGP path, because eBGP has a AD value 20, right? And iBGP has a AD value 200, right? Lower IGP reach to the next stop. If you're running with the IGP, I'll explain this thing later on. So these are my attributes here. The first we are forming the navigation. The first, yes. So these are my path attributes, right? These are my path attributes. When a BGP router receive a update, right? These are the path attributes, and based on these path attributes, the router is going to decide which one will become the best path or which one will become the second best. Based on this one information, the router is going to decide which one is the best one and which one is the second best path. And based on also this thing, the router is going to perform the route manipulation. If the next hop is reachable, if the next hop is reachable, right? If the next hop is reachable, then we'll go for attributes, because that's the most important. If the next hop is not reachable, the router BGP router never mark that route as the best and valid, right? And if the route is not a best and valid, the BGP attributes number comes in the picture, right? Next hop must be reachable. So try to understand one thing. If you see right now, okay. So we have a ace number one, we have a ace number two over there, right? We have a ace number, what happened? Ace number three. So three ace number we have, okay, and this guy's ace number four. We can assume that this is the ISP, and we have a some dot behind the ISP, right? I think so. Used to play it or something. Router number one, router number two, router number three, and ISP. right? So if you just have a look the show IP interface brief, router number one, and also all the pre-configuration of the BGP show IP interface brief, export on assign. So all we have IP addressing on the router number one, right? And guys, always please verify the pre-configuration of the router. Always before doing any configuration, please verify the pre-configuration. Okay, not in the examination, in the real world as well, as because your single command, your single extra command will cause a lots of memory on the router. At the same time, it will make a router failure as well, as because if you don't have enough memory, right? If you don't have enough memory, you cannot take a telnet access of the router as well, as. And if you turn the storage system BGP, so can you see that we have a router BGP one, that's configuration with the 12.2 and 12.3, right? All good. So I'm present router number one. So if you see, I have a neighborship as well as so IPVGP summary. All good. If you go back to the router number two now, all we have IP addressing, right? And we see the storage system BGP. Everything is good on a router number two as well as. If you go back to the router number three now, all good. And if you go back to the router number four, that's my ISP. So show IP interface brief. It has three loopbacks, okay? And storage section BGP and all good. And if you check the show IP BGP summary now, R4 is going to form the navigation with the every question. Right, so this is my BGP table version. It's how many times your table has been updated, right? And this is the BGP version. Now try to understand one thing. I'm just going to capture this way. The point is, when R4 is going to advertise this, I'm just taking example right now, one information, right? I'm just going to advertise the one information right now. Router BGP number 4, network 4.0.0.0. You know what happened as I told at this point? When a BGP router advertises some information and write information, they put this data information in the BGP update packet. At the same time, what happened? But at the same time, what happened? BGP put some extra information about that route. That extra information is known as a BGP attributes, right? And based on the BGP attributes, they will perform the best path selection, right? This information, this theory, right? If you see right now, once I put this network 4.0.0, let me do one thing. I'm going to enable some debug over there. So when R4 is going to advertise this information out of BGP number one, sorry, can you see what happened? R4 is sending the update packet. R4 is sending the update packet from the 24.2, right? Can you see? So R4 will send this update packet from this guy and this guy as well as. Which update they are putting the 4.0.0.0.0.0 and 4.0.0.0.0. R2 will send the same update to the R1 and R3 will send the same update to the R1. 4.0.0.0.0.0 and 4.0.0.0 because R1 has a neighborship with the both person, right? R2 and R3. If you see, R1 has a neighborship with the R1 and R2. Anyway, if you check the R2 has a neighborship with the both person, so IPGP summary, right? And R3 also have a same neighborship with the R4 and R1. So everyone has a correct neighborship, right? There's no issue. But so what happened in this case when R4 will send this update to the R2, R4 will send this update to the R3, R2 will send this update to the R1, R3 will send the update to the R1. In that case, what R1 is going to do? If I'm going to talk about the EIGRP perspective, right? Right now, if I'm going to talk about the EIGRP perspective and the OSP perspective and the RIP perspective, what happened? They will perform the load balancing. Am I right? They will perform the load balancing. Why? Because they have an equal cost. They have an equal cost from the both the side. At the same time, what happened in your R1 or not R1? We can say that for what happened for this all this protocol, right? For all this protocol, your maximum path is what by default 4. And this guy is going to represent that, hey, you need to perform the load balancing. This guy is going to represent that you need to perform the load balancing. Because maximum path is 4, it means that I can receive the update. I can receive the update in the 4 ways. On a 4 interface, I can receive the simultaneously, right? Simultaneously, I can receive the update from the 4 path. Simultaneously, I can receive the update from the 4 path. If you have a look over there right now, just going to run the any of the routing protocol. Take example, same thing I'm going to run router HTTP number 1. I just want to show you something, right? Not this one. I'm not interested in this one. 1 minute. Otherwise, 80 probably will happen, right? Can you see on R1 what happened? So IP route. Try to understand. Try to understand. I'm running with the. I advertise this 4.0.0.0.0 in the BGP, right? And 44.0.0 in EAGRP. R1 has a both neighborship. If I'm talking about the EHRP perspective, they have a both neighborship. If I'm talking about the BGP perspective, they have a both neighborship. But you know what happened? The main difference is happening over there. You see router number 1. I'm receiving a 4.0.0 from both the ways, and I'm able to perform the equal cost load balancing just because of the maximum path. This is the EHRP. If you see show IP protocol now, if you see the what is the protocol EHRP saying that hey, my maximum path is 4 by default. I can receive simultaneously I can receive the update from 4 ways. But what BGP is saying that hey, I have the ability one. It means that by default, the BGP router is not going to perform the load balancing. This is the default behavior, whereas the EHRP is doing. So that's why if you see one thing, right now this topology is running with the EHRP and BGP both of them, and I have advertised the 44.0 through the BGP, right? I'm performing the load balancing. At the same time, 4.0, I have addressed to the BGP. What happened? I'm not doing the load balancing just because of the. Now, hope this thing is clear to all of you guys, right? What we need to find over there, we just need to let me. I'm going to disable the HRP right now. I want to just show you the this area maximum path, right? What I'm trying to show over here, right? My point is very clear. When R4 is sending this update to the R2, right? Which update 4.0.0.0.0 and 4.0.0.0.0, they'll put some extra information in the BGP update packet, right? If you see the BGP update, so the BGP. So if you see the network layer reachability information, right? 4.0.0/8 prefix length, that's a subnet mask information, and prefix means what we have a network. Can you see the update path attributes information? We have a ACE path information, we have a next step information, we have origin port, that is IGP, right? Like this part. So we have some extra information, right? These are my extra information about this particular route, and depend on the like you know What I would say that depend on the technology like route vector configurations and like community, many things, right? Depend on the technology, this attribute will be changed over there. If you remember that if I'm going to implement the IGP protocol, do we have this information? No. But if you're going to implement the route reflector, you will have a originator ID and cluster ID over there. At the same time, if you're going to implement the IBGP, right? If you're going to implement the IBGP, internal BGP, you will have a local preference over there. So depend on the requirement, right? Depend on the technology, this attribute will be changed. What this attribute is just going to tell, this just going to tell the extra information about this particular route. This just extra information, right? So now the question is that when R1 is receiving this update, right? When R1 is receiving this update, which one R1 will make up best? Because my router is saying that hey, maximum path is one. I need to make one of the best, right? Either R2 or either R3. I'm just going to make the best either R2 and either R3, right? But which one? That's totally depend on the BGP path attributes. So try to understand one thing. What is my first attribute we have right now? Weight. What is the weight is there? Higher preferred, right? Higher weight is more preferred. I'll tell you one thing first on the weight. Or locally originated. Or learn route. The range of weight 1265530, 16 bit of number. Lower is more preferred. So if you see right now for locally originated route, the weight will be 32768, right? So if you just go for the router number 4, because router number 4 is advertising this route. Can you see do show on section BGP? Router number 4 is going to advertise this route, right? Locally originated. So if you see on a router number 4, the weight will be what? 32768. And this weight, right? This weight will be never advertised in the update. It's local. So this is the information of the weight, right? These are the information. So if you see for locally originated, we have a weight 32768 and it's never advertised in the update packet. So can you see, is there any weight information is there? No, there's no information on the weight, right? So if you see when R4 is sending this update to the R2, when R2 is sending this update to the R1, right? So at the same time, when I put the network statement 4.0.0.0, what is the weight over there? 32768, right? But R1 is learning, right? It's learning. It's locally originated, right? It's learning. For the locally originated, the weight will be 32768, and weight will be never travel. The weight never travel in the update packet. So what about the R1? R1 is learning. For the learning, what is the weight? Zero, right? So what happened in this case? From this side, I'm also have a zero weight, and this side I also have a zero weight. And what I'm written over there, I written over there higher weight is more preferred, right? But in the both side, what happened? I'm getting the weight is zero. So if you see right now on R1, what is the weight is happening? Show IPBGP. From this path, 1202, that's actually a R2, and 1303, that actually a R3. The weight is zero, right? So what happened? Router 1 is not able to perform, right? Router 1 is not able to perform the selection of the weight. It is something, 1 minute. Let me do one thing. Let me write on this thing in the notepad. I need to one every time in the field. Our the first attributes, BGP attributes, next of most visible. Right, the first attribute is the weight. Higher is more preferred, right? It's local to the router, right? For locally originated, weight is what? 32768. And then for, so this is the extra information. So I'm just going to put in the tab space over there. And for learn routes, the weight will be zero. The range you can define from 1 to 6553 or 16 bit number. I think so. This is big. Local preference. Default is traffic seen in IBGP. Third is self-originated. Then we have a version AS path. Lower is more preferred, right? Then we have a origin code. Then we have a MED. MED is a metric of the BGP, right? Then we have a BGP ED, because eBGP ED has a 20, right? It's a 20 ED and it's a 200. Then we have a IGP cost. Then we have a eBGP ED, oldest path we can say that. Only only for eBGP, not IBGP. Then we have a lower neighbor router ID, lower neighbor IPs. So try to understand when R1, this one information, right? When R1 is receiving the weight is zero and weight is zero from this side, what happened? The same weight, right? So this attribute will be time. So now the router one is not going to look up for the this attribute. It's time, because from both side I'm have a zero zero from both side. From the both side I have a zero zero, right? Can you see that now? Right now I'm just going to telling you why R1 is preferring this guy the best. Just I'm going to tell you why R1 is going to prefer this guy the best. So right now we are just trying to understand what is the selection criteria. Then what happened if this guy will be a tie? Then it will go for the local preference side. What the local preference is coming in the R1? If you see empty value, we can say the zero, right? It's empty because in EBGP you cannot see the local preference. It's only seen in the IBGP. Default is 100. That's seen in the IBGP. So again, this guy will become the tie because I have a EBGP, right? I have a EBGP. I have a EBGP between the H number. I'm going to run the EBGP, right? So again, this guy will be tie. Then it will go for the self-originate. Self-originate means what? It's a locally originated. Is it locally originated route? It means that when R4 is sending this update to the R2, right? When R2 will send this update to the R1. When R4 send this update to the R3, when R3 send this update to the R1. So in this case, what happened? R2 is sending this update to the R1 and R3 is sending the update to the R1, right? What happened if R1 is also going to advertise this update itself? It means that it's a locally originated. In that case, what happened? I'm learning, I'm learning this update, right? I'm learning this update at the same time. I'm learning R1 according to the R1 perspective, right? According to the R1 perspective, I'm learning this route. At the same time, I'm locally originated this route. So I'm always give the preference to the locally originated. That's the meaning of third one. I'm locally originating, right? I'm advertising this route. I'm not learning, I'm advertising. So if I'm learning at the same route and if I'm going to advertise this at the same route, I always give the preference to the this person, locally originated. So right now, again, from both the direction, right? From the both the direction, this one and this one, I'm just learning. I'm not advertising, right? I'm not locally advertising this route. So in this case, what happened again? This guy will become the. Then after that, it comes to the ACE path information. Lower is more preferred. So can you see right now, as we know that ACE path is going to prepend, right? Every ACE path information will be prepend. So when R4 is updated to the R2, so what ACE node is putting 4.0.0.0.0.0, ACE number will be 4. Same from this side, right? Because it's going to prepend the own ACE number. When R2 will send this update to the R1, they are going to prepend the own ACE number. He said that, okay, let me put the 2 and 4. When R3 sends this update to the R1, he said a 4.0.0, and he said, hey, let me put the update 3 and 4. So if you see on a R1 BGP table, you have the same information. Can you see that? 2 and 4 and 3 and 4. So what is the range of this one right now? Both have a 2 2. From this side, I'm getting the 2 A's path information, and also I'm getting the 2 A's path information from this side, right? So again, this guy will become the time because lower is more preferred, right? If somehow, take example, if I'm only getting the from the one or A's number from there, right? Just one is a 4 only, or any single A's number, then I'm going to make the R2 as the best. But right now, I'm getting from the both sides are equal, right? From both sides is equal. 2 from this side and 2 from this side, right? I'm not going to make this guy the best again. Then what happened? After that, it will go for the origin code. How many origin code we have? 3 origin code, right? As the name suggests, if you just have a look the name of this person, right? If you just have a look the name of this person, origin code means your originator code. What is the source of this route? In a simple language, source means what? How we are advertising this route. For example, we have 3 types of code. We have a IGP, we have a EGP, and we have a incomplete. IGP means what? I'm getting the I value. EGP means what? I'm getting the E value. And incomplete means what? I'm getting the question. We are not going to discuss about this person because this is totally a legacy now. It's totally legacy. We are not going to use this. Is the if you remember that in the first of the BGP class, I already informed you that this protocol EGP. EGP means what? Before the BGP, we had a EGP protocol. So on that time, this things was there, right? On that time, but now it's not there. And you will never see. You will never ever see. So we are not going to discuss this thing. So now, how many values do we have? Just to have two, right? So IGP means what? IGP means what? If you're going to advertise your route 1.0 for your network 1.0, in this case, what your flag will be? That's how. What is the source of this route? How we are advertising. And if you perform the redistribution, right, then you will see the incomplete. I'm again repeating this. Multiple things are there. If you go in the much detail, this code will be a little bit changed, right? But right now, for the understanding purpose, this is the main reason. So right now, what happened? I is more proper than question. It means that if any route, for example, if router number one, if router number one is receiving a one route from this direction and this direction, what happened? If this guy has a 1.0.0.0 origin code I, and if this guy has a origin code incomplete, I'm going to make this guy the best because I is more proper than E. Oh, sorry, incomplete. So right now, if you see, what is my origin code right now? I'm using the network statement, right? And if I'm going to use the network statement, if you go for the router number 4, I'm using the network statement 4.0.0. So what will be the origin code? And even if you check from R1, what happened? I'm getting this route, right? I'm getting this route 4.0.0 from R2 and 4.0.0 from R3. What is the origin code is happening? I and I. Again, the type will become. If somehow, if this person will become the incomplete, then I'm going to make this guy the best because I is more proper than incomplete. But right now, from both the side, I'm getting the II. Can you see the update? IGP, right? I means IGP. The I means IGP. So from both side, I'm getting the I, right? So I'm not going to make anyone prefer, right? If you see incomplete, I'll show you the incomplete as well as what I can do. I'm going to create the route map. Just go for mid 10. Match IP, match interface loopback number. Can I do that loopback number too? Am I right? To show IP interface B. All good. And I'm going to say the router BGP number 4, redistribute connected route map. Update message 24.4 is sending to 24.2. Can you see incomplete is there for this route 44.0.0, right? Incomplete is there. So if you put right, if you put your redistribute statement over there, you will always see the income. If you see to show IPVGP now as well as I and question mark. This question mark is incomplete, and this I is. Guys, till this point, we didn't identify which one is the best route. Let me remove the route map. I'm not interested in this one right now. All good. So what happened again? This guy will become the type because from both the side, right? From both the side, what happened? I'm getting the same origin code I and I from this side. So again, this guy will become the type. Then it will go for the MED, right? Metric. If you see the metric value from both the side, it's 0. So IPBGP from both the side metric is 0, right? It's empty. 1 minute. So IPBGP from both the side, what is the metric is 0, 0, 0, 0. So again, what happened? This metric will become the, because metric also I'm from the 0 this side and 0 this side. So again, this guy will become the time. The next one is the BGP AD value. eBGP path over the iBGP. It's simple, like it's everyone know that if R1 is receiving a one path with a 20 AD and one path is a 200 AD, I'll always give the preference to the 20 AD. Lower AD is more preferred, right? So that's very simple. It's something like that. The term is saying that this point is saying that BGP AD, eBGP path over iBGP. It means that let's take example. We have a one topology over there, router number one, right? Router number two, and router number three, right? So in this case, what happened? I'm going to run with the IBGP over there. And this guy is going to AS number one. This guy is running with the AS number 2, 3, right? And this guy is actually AS number 2, 3, and this guy is AS number 3 over there, right? So what happened? This route behind the R, this between this link R2 and R3, we have a 23.0/24. So in this case, what happened? Try to understand R3. Sorry, R2 will also send this update to the R1. Which update? This update. How? Through the IBGP. So what will be the AD on this person? The AD will be 23.0 with the AD will be 200. At the same time, RC will send this update to the R1. How? Because of the eBGP. So 23.0 AD will be what? 20. So what happened? R1 is going to make a eBGP as a test, not the IBGP. It's going to make the eBGP as a best, right? Because eBGP has a lower AD, right? So eBGP path is more preferred over the IBGP, right? Because of the AD, right? So again, what happened right now in my topology, all we have a eBGP, S1, S2, S1, S3, S2, S4, S3, S4. All we have a eBGP. So again, what happened? This guy will become the. So till this point, I didn't identify which one is the best one. Can you imagine that? How BGP is powerful as compared to the IGP. Then it will go for the next one, IGP cost. Do we have any IGPs enabled over there? No. IGP means what? I'm talking the OSPP, GRP RIP. No, I don't have the IGP, right? So again, this guy will become the. All this guy become the tie, right? Now it will go for the eBGP peering. Oldest path. So eBGP means what? It's only applicable. This statement is only applicable for the eBGP, not for the IBGP. This statement is only applicable for the eBGP, not for the IBGP, right? So in this case, what happened? Both are eBGP, right? What is in the oldest path? To whom I'm forming the first neighborship. to whom I'm forming the first neighborship. So if you just have a look right now, this is my oldest one, 1303. R1 has first formed the neighborship with the R3. R1 has first formed the neighborship with the R3. So it will be the oldest path. Then after that, R1 is forming the neighborship with the R2. So the first they have formed the neighborship with the R3, and then they have formed the neighborship with the R2. So this will become the oldest path, and that's why it's a best path. And because of this reason, this path will be installed in my routing table. Because of this oldest path, can you do like this? Can I make this guys right now? Who is the oldest right now? This is the oldest, right? This is the old one. This is the new one, right? Because first this neighborship has comes up, and then it's first this neighborship has comes up, and then next one is this one, right? Look at this now. What I can do right now, I'm just going to make this guys a older. How? Try 3. I'm going to shut down. I'm just going to right now. This is the older, right? I'm going to make this guys a new. How? I'm just going to shut down this guy right now. So now this guy is a shut down. So right now there is no neighborship, right? So now what happened? This new will become the old. And if I want to say the no shutdown, what happened? This will become the new. So now again, previously R3 was best, right? Previously R3 was best. Now R2 will become the best because now R2 is older. Previously, if you see R3 was best, right? 13.3. Now R2 is best. Again, if I'm going to say a neighbor, take example 12 or 2 now. Shut down. Now I'm going to make R2 as a shutdown. So it will become what happened again as the no shutdown. It will become the new one. So what happened now? R3 will become the old one. So again, R3 will become the old one. So oldest path will be best path. And this is the new route. This is 25 seconds ago. We just learned, right? So this is the tiebreaker, guys. This one is my tiebreaker for the EVGP path. This one is my tiebreaker just for the EVGP. Can you imagine? What I want now. I'm coming to this point later on. Don't worry about that, right? What I want right now, try to understand. R3 is the best, right? What I can do, I want to make R2 as the best. Okay, before I'm going to explain this thing, I'll tell you something else as well. Okay, traffic, and we have two types at the same time. Update. We have about two types. Inbound, and this is the traffic update is also inbound, and update is also outbound. So both are different things. This one is a different thing, right? And this one is a different thing. Traffic means what? When you're sending your packet, like telnet, SSH, ICMP, ping. Ping is a command actually, right? It's not a traffic. Ping is a command that generating a traffic. It's a command that generating a traffic. Update means what? When you receive update. And both are opposite. If you see right now, router number one, right? Try to understand. This is router number one. If you understand this point, your path attribute will be clear. If you're not able to understand, your path attributes will become the hard. Just last one. Try to understand one thing. If update is coming, right? Let me do one thing. So let me talk about the traffic perspective first of all, right? If you have a route in your routing table, as the BGP 1.0.0, and I'm getting this out from the 13.3, that's the 13.3, right? So you have a route in your routing table. So if you have a route in your routing table, what happened? I see the ping. So if you see the ping, what happened? You are generating a ICMP traffic, and that you are sending. So this will become the outbound traffic because you are sending from this interface. You're sending from this interface. What happened after you're sending the ICMP request? You are getting the reply as well as ICMP reply. So now you are receiving, you are sending the ICMP request, right? You are sending this ICMP request from this interface. This will become the outbound. But when you're receiving the reply on this particular interface, what happened? This will become the inbound. For which person? For R1 perspective, right? For R1 perspective, the outbound and inbound will be defined because you are sending the traffic, right? Because I said the ping. At the same time, when you're receiving the update, for example, some another router behind this guy, and they are sending the update to you. And this update is a 4.0.0.0.0. So you're receiving this update on which interface 0/1. So this guy will become the inbound update according to the 0/1, right? according to the 0/1 perspective. But when you're sending this update out of this interface, what happened? This will become the, this is the same update, but this is the odd one update according to the 0/1 interface. Same thing when I'm receiving the update on this particular interface, 0/1, sorry, 0/0, the another update we have a 2.0.0.0. So what happened? This update is known as a inbound according to the 0/0, right? Because I'm receiving. But when I'm sending this update, when I'm sending this update from 0/1 interface, what happened? This update will become the what? No? So can you see that depend on the flow, right? Depend on the flow, this outbound and inbound will be changed. So can you see, I'm sending the traffic from this interface 0/1, sending, I'm receiving on the same interface. So sending is out, receiving is in. Same way, when I'm sending this update from this interface, this will become the outbound. So right now on this particular interface, it's an inbound, and when I'm sending it out from this will become the outbound. And both are, guys, opposite. Opposite in the sense of what? We can say that inbound update, inbound update is just the opposite of outbound traffic. What's the meaning of that? And same thing, outbound update. So the meaning of that, the first line. The first line is saying inbound update means what? So this is the update that I'm receiving, right? Once I receive the update, I will put in my routing table, then I'm going to send the traffic. Because after receiving the update, because in the update packet, what happened? In the update packet, you will have a routing information. In the update packet, you will have a routing information. So once you receive the update, I will put that update in my routing table, and after that, I will see the ping 4.4.4.4. So this will be your traffic that you are sending. So this will be your outbound. So inbound update, right? That's I'm receiving inbound update that I'm receiving is just opposite of outbound traffic that I'm sending over there. Same thing happened with this person now. So outbound update means what? Outbound update means something like this. So when you're advertising the update, when you advertising your update, once you advertise the update to the neighbor, once you advertise the update to the neighbor, it's something like that. R1, R2, 1.0.0.0. So once you advertise the information to the R2, right? That's the outbound update that I'm sending, right? According perspective of the R1, you have to think perspective of the R1, right? So when R1 is sending this update to the R2, R2 will maintain this update in the BGP table 1.0.0.0. Once R2 will maintain, now R2 is sending the traffic to you. So this traffic will become the inbound. Now it's clear. Hope. In BGP, we always going to manipulate the update. So if you're going to manipulate the inbound update, right? If you're going to manipulate the inbound update, we have a few attributes mostly. Wait, and it's recommendation to use this thing, local preference. Both are higher prefer. Both are higher prefer. Both are. So if you just have a look right now, according to this topology, right, you have to think according to the R1 perspective because users are sitting on R1. So when R4 is sending this update to R2, when R2 will send this update to the R1, when R4 will send this update to the R3, and then R3 will send this update to the R1. So he's sending what? Update, right? R4 is saying this what? Update. So according to the R1, is it a inbound update or outbound update? According to the R1, it's a inbound update. According to the R1, it's a inbound update. So for the inbound update path manipulation, what I can use over there, I can use the wait, or either you can use the local preference. So first, I'll show you the wait, how we can manipulate the path. What I'm going to do right now, the what is the wait is happening, 0 from this side and 0 from this side. What I'm going to do, I'm going to make this guys a 100. I'm going to make R2 should be become the best path because as it this is the first attributes, right? The weight is the first height is more preferred, right? And it's local to the router, it's never addressed with my neighbor. So locally originate for the 32768 and learned outside 0. A range we can define from this one. What I'm going to do, I'm just going to apply the weight to for this particular name. Right now, if you see which one is the best, one is 30.3, right? And what is the weight is 0 from this side and 0 from this side. And why R3 is best? Just because of the oldest path. Just because of the oldest path. What I can do over there, just go to router number 1 and say the neighbor 13.3, sorry, 12.2, right? I'm going to say the weight will be, define any weight from this one. I can say the 100, right? Do clear IPBGP history. Now can you see show IPBGP? Previously, R3 was best. Now R2 will become the best just because of the weight. So if the criteria match over there, right? If this criteria is matching on the weight, it will never perform the lookup for the rest of the attribute. If the match will happen at the first, if the match will happen at the first, I'm not going to look up for the remaining attributes. So I have set the weight 100 on this particular neighbor. So can you see whatever the update now R4 is saying, for example, 44.0.0 and network 172.16.1.0. Whatever the update now R4 is saying, whatever the update, all this update, right? All this update is coming to the R1 from the R2 and R3 as well as. But on the R1 side, what happened from this particular neighbor, I have set the weight 100. So what happened? R1 for all the route, for all the route, what happened? R1 is going to make R2 as a best one. Can you see? 12.2, 44.0, what happened? 12.2, and 172.16 and 1.0/24, what happened? 12.2, just because of the, because I have applied the weight to the particular neighbor. Can you see in my command line? Show run section BGP. For the particular weight, for the particular neighbor, I have set the weight 100 over there. So if you see show IP root BGP event, right? My all path, my R2 is the best for every single network. Whatever the network that is coming in the future as well as for every single network, what happened? This R2 is the best. Because higher weight is more preferred, right? And weight will be never exchanged in the update. So if I set the weight on a router number 1 towards the neighbor 12 or 2, Will R1 share this information with R2? Of course not. If you see on R2, I don't have any weight information. Can you see? Is there any weight information happening on router number 2? No, of course. So you can just change the weight by using this command. You can just go on the neighbor and say that hey neighbor weight will be here, and this you can define the from 1 to 65535, right? So this is good, right? We can achieve my task right by using this thing. But do you know what happened in this case? Do you know what happened in this case? For every single route, R2 is the best. For every single route, R2 is my best. What I want. Let me remove the weight now. What happened? So this is the oldest neighbor right now. What happened? I want to make this guy. I want to R2 as something. Right now, what happened? Weight is zero, right? Weight is zero. From this side, weight is zero. What I want, my task is very simple. 1 minute, let me take a screenshot of this thing. Oh, come on. And why we are going to use the weight, guys? So in one update, right? According to the R1 perspective, you have to think you are present on a R1. So for inbound update or outbound traffic manipulation, we are going to use the weight and local preference, right? And both are higher preferred. Both are higher preferred, right? You are present on a R1. You have to think according to the R1. So now if you see what I'm going to make this guy for this one for 44.0.0.0.0.0, right? R2 will become the best, and 44.0.0 and 172.16.0 R3 will become the best, so that we can utilize both links, so that we can utilize this link as well as, because this is also 10 Mbps link and this is also 10 Mbps link. We can utilize both of the link. For this one, what happened? The policy comes in the picture because I want to make right now. What happened? If you see right now, R1 is making R3 is a best for every route. Okay, 1 minute. Okay. To show IP BGP now. So I will get yes to show IP BGP. You can see for every person what happened. R2 is the best for every person. What is my task over there right now? My task is very simple. 4.0.0 R2 will be best, and 44.0 and 172.16.0 R3 will be best. So in this case, what happened? I need to do the policy, right? When the policy comes in the picture, we need to do the ACL and plus dot map. So what I'm going to do is step number one, print ACL, or we can go for the prefix list as well as to match the route. So access list number one for me, I'm going to match the 44.0.0, right? Step number two, print route map and call the ACL. Set the route map. Just go for me 10 match IP address. what one, and I'm going to say the set wait for which person is still number one. I'm going to make this guy the 10,000. I just want to say R3 should be best, right, for this route. So I'm going to make this guy the best, match the route, because right now R2 is the best, right, for every person. R2 is the best. 1202, 1202, 1202. I want to make this guy the R3 is the best for this particular route, right? And simply go now route number one, and I will clear this one. And for the remaining route, what happened? I need to allow this all person, right? So commit 20. Step number three, apply. How do I apply? I just need to go on the router BGP number one. I said the neighbor 13.3. Not, yep. I said the route map. So let's go. And is it an inbound update or outbound update? It's an inbound update because right now R4 is sending this update to R3 and R4 is sending this update to the R2. And you are present on which router? You're present on a router number one. So you have to think according to the R1. So R2 is sending this update to the R1 and R3 is sending this update to the R1. So for R1, for this person, what happened? This update is a inbound, right? This update is a inbound. So what happened? I need to go on the router number one. I say that neighbor 13.3, the update will be inbound to clear IPVGP streak. So now do one thing. Let's copy this guy, make it comment, make it this comment, and make this guy as a comment, and hit enter. Router number one. So now, if you see for this particular route, right? For this particular route, 4.0.0 and 172.16.0, R3 will become the best one, just because of the weight, just because of the weight, right? And of course, the default one is a 4.0.0.0.0 That's the default one because oldest neighbor is the R2 is the oldest neighbor, so R2 will be the best. So in this case, what happened? You can utilize the both of the link. All good. So this is the configuration, guys. It's very simple. You already know the ACL and you already know the route map. I just need to apply this thing, right? And that's it. If you have any questions, you can ask me. Again, in the configuration point, if you don't put the route map Cisco 20, what happened? The implicit deny will be happen, right? Implicit deny. The implicit deny will be happen. If you see right now, if you don't, if I'm just going to remove the route number 20, no route map Cisco 20, and declare IPv6 sticks off now. See, implicit deny is happening. So the difference is output. Can you see? So from R3, I'm not able to receive the backup path for the 4.0.0. Previously, you see, I'm able to receive the backup path from about this particular route, right? About this particular route, I'm receiving the backup path, right? But now, after remove the permit 20, what happened? I'm not able to receive the backup path from R3 about this 4.0.0. It means that if this link goes down, what happened? If this, just take example, if this link goes down for this particular route, we don't have any backup path because route map is denying. Route map is denying for this 4.0.0.0.0 route map is denying from this particular link. So that's why we need to allow the remaining route, right? That's why we need to put the route map Cisco permit 20. All good now, good to go. But do you know what happened? What is the problem with the weight? Why we are not going to prefer the see? It's not like that we are not preferring the weight. It's depend on the requirement. If you have a requirement, you can prefer the weight. And what requirement? The first thing is that weight. The first issue with the weight is that it's a Cisco proprietary. It's only done on Cisco device. Actually, this is introduced by the Cisco. And another thing is the weight is used to that it's local to the town, not AS. AS is what? It's a collection of route, right? AS is what? It's a collection of router. So it's not a AS, it's a local to the router. It means that if you have a look like this topology, right? If you have a look like this topology, for example, if you have a IBGP over there, right? So R1, R2, R3 is present the same H number, right? R1, R2, R3 is present the same H number, right? So if take example, if if R2 is going to manipulate the weight, for example, 1000, do you know what happened? It will never affect on this particular user. It will never affect on this particular user, and it will never affect on this particular user because it's a local to the router. It never advertised in the update map. The first issue, the weight is a Cisco proprietary, right? It's only done on the Cisco devices, and another is the weight is a local to the router. If you're going to configure on this person R2, R2 will only affect the own path for this particular user. What happened? This particular user, the path will be affect, right? But not for this one, not for this one, because still they are possessing the same H number R1, R2, R3, possessing the same H number, but it will never affect on this user and this user just because of the local to the router. All good. So to avoid this problem, what we have introduced the next concept that is known as a LP value, local preference. So what I can do right now, if you see, I'm just going to router number one. First, let me change my all the configuration. I said no router BGP, no route map first of all, Cisco, no access list number one, and no router BGP. I need to modify my all configuration, right? Because I need to run the IBGP between the R2 and R3. Sorry, it should be three. It should be four. Remove this guy. It should be two now. Now it should be R1 dot BGP number 123. Neighbor I am to form the neighborship with the 20.3. Remote H will be what 123. And neighborship I'm going to form with the 30. Oh, come on, 12.2. Uh, should be 123. Right? R1 has done. Now we have to go on a router number two. Router number we need to go on the router BGP 123 and neighborship I'm going to form with the 12.1 that has a neighborship with the 123 and neighborship I'm going to form with the 24.4, right? And that has a neighborship with the R4. That's perfect, right? And let me go to R3 now. Router BGP number 123. Neighborship I'm going to form with the 13.1 that has the same H number 123. And neighborship I'm going to form with the R4 that is a H number 4, right? Now router number 4 I'm going to form the neighborship with router BGP 4 and I'm going to form the neighborship with the 24.2 that has a remote H will be 123. Neighborship I'm going to form with the 34.3 and that has a neighborship with the All done. So we have a negotiation with the, okay, what happened? 24 or 2. Why I'm not getting the negotiation with the 24 or 3, right? It has to become, okay, some command is down. 34 or 24 or 3. 24 or 3, HTML 1 to 3. Yeah, all good, right on the side. Out of 3, I'm following the negotiation with 13 or 1, but not for this person. Why? It should be good, right? Yep. Just wait for some time, maybe. Hmm. It's correct, right? Do ping. Can I ping this guy? Because rigidity must be there, right? I'm having to ping you, right? Idle state. Why? Oh, my mistake. It has to be, right? No? All good? Come on, man. Wake up. Yep. So now try to understand if I'm going to advertise the route from R for 4.0.0.0.0 and 44.0.0.0 and 172.16.0. It's a classless. That's why we need to put the mask keyword, right? For the class code, we don't need to. Now try to understand what happened when R4 is sending this update to the R2, right? And when R4 is sending this update to the R3. Okay? Which update I'm talking the 4.0.0.0.0 and 4.0.0. R2 is the IBGP, right? R2 will send this update to the R3, R1, R3 will send this update to the R1. So in this case, what happened? As we know that by default, the behavior IBGP does not change the next hop and EBGP does change, right? We have seen this thing if you remember the configuration part. So in this case, what happened? Whenever the BGP router received the update, right, it first check the next hop reachability. If the next hop is not reachable, I cannot make that route as the best. So if you see your router number 1, is it next hop is reachable? If you see, still what happened? 4.0.0.0 when R4 is sending this update, it's putting the next hop 24.4, right? And it's putting the next hop 34.4. When R2 is sending this update to the R1, it's same putting the 24.4 and same putting the 34.4 because IBGP does not change the next hop. IBGP is running over there, right? So can from R1, can I ping this guy 24.4? And can I ping this guy 34.4 from R1? Of course not. We don't have reachability. 1 minute. Something is a mistake. Wait for some time. It's a little bit slow routing the guys. So always we need to have a good patience level, right? Yep. So my name is comes up, right? So if you see on a router number 1, what happened? Not a best one because my next hop is not reachable. Can I ping this guy? Of course not, right? So if your next hop is not reachable, I cannot make this route as a best. Can you see that it's only valid route? It's not a best. So if the route is not best, can I install this route in my routing table? Of course not. So what happened? I just need to go on the router number 2. That's the default behavior. IBGP does not change the next hop. So what I'm saying the router number 2, hey, whenever you're sending the update, whenever you're sending the update to the router number 1, 12.1, please change the next hop. Same thing I need to repeat on a R3. Hey, whenever you're sending the update to the 13.1, please change the next hop. You need to apply the own next hop 13.3 and you need to apply the own next hop 12.2. So now better to come on R1 and now if you verify the same thing, show IP root BGP, first show IP BGP, what happened now the next hop is change 12.2. Previously 34 and 24. Now 20, 12, and 20 or 20 or 3. And now I'm going to put this out in my routing table because this is my directly connected route, right? This 12 or 2. From R1 I can ping the 12 or 2, and from R1 I can ping the 13 or 3. This is my directly connected, and I will make this guy as the best invaluable. And as the route is best and valid, you can install this route in my routing table. So we can install this route in my routing table, right? What I'm going to do, guys, now. So right now, why R1 is going to prefer R2 as the best? I'm receiving the path from R3 as well as, right? Do you know why? Just because of the this person now. Lower neighbor route ID. We have seen this point, right? The EVGB. Now the path selection is coming for the IBGB. This is only for the IBGB. This is only for the IBGB. So now what happened? Lower neighbor route ID, right? So in this case, what happened? If you see what is the route ID of R2? 2.2.2.2.2, right? What is the R3 route ID? 3.3.3.3.3.3, right? So what happened? R1 is receiving the update from which neighbor? R1 is receiving the update from R2, and R1 is receiving from R3 as well. So which one is a lower route ID? 2.2.2. That's why I'm going to make this guy a best. If you see that, I can prove it. I'm just going to router number 2. I said the BGP router ID will be 200 or 200 or 200 or 200. Now tell me which one is the lower router ID. Now this guy has changed with the 200. So now this guy will be lower, right? So if this guy is a lower, so I'm going to make R3 as a best. So let's go now. Show IP route, show BGP, and so IP route BGP. Can you see now? Changes happen just because of the lower route ID. So this two attributes, right? This two path attributes is only comes in the picture whenever you're going to implement the IBGP. This is only for the EBGP. And rest of this guy is there for the IBGP and EBGP, both of them. So again, if you go back to the router number 2 and say that, hey, now your router ID, let's make it original one. What happened? Now this guy will say, hey, my router ID is lower, right? So in that case, what happened? R1 is going to make R2 as a best. Previously, R3 was best, right? Now, and can you see this I, right? This I is going to represent that it's an origin code, right? And this I is going to represent that it's learned by the IBGP. Two different things are there, right? This I means what? This I means IGP. This I means origin code. Sorry, IBGP. Now have a look, guys, over there. So what happened now? I'm in the 12 or 2. Why? Just because of the lower neighbor route ID. Now, what happened if you have a look like this topology now? Take example. Router 1, router number 2, and we have a 2.0.0. What is the router ID of this guy? What is the IP address on this person? So now try to understand when R2 will send this update R1, and when R2 will send this update to the R1. What is the router ID? Same router ID, right? So once the router ID will get tie, then it once the router ID will get tie, because in this update also router ID 2.2, in this update also router ID 2.2.2, right? And because I'm getting the same update from the same router, but we have two different neighborship, right? So in that case, what happened? I'm going to make this guy the lower neighbor IP address. So in this case, what happened? This guy will become the best lower neighbor IP. right? So hope this thing is clear to all of you guys, how this attributes are working fine. Now let's come back to the this point. What I'm trying to say that I want to manipulate the path. Right now, what happened? R2 is the best, right? Right now, R2 is the best just because of the lower router ID. I want to make this guy as the best, R3. And I'm running with the IBGP. I want to manipulate the path for R1 as well as. How do I do that? I just need to change the local preference because weight is not preferred, right? Because weight is a local to the router. Because if I'm going to manipulate the weight on this guy, it's only effect on R3, not on R1. But if I'm going to manipulate the local preference on a R3, it will manipulate on a R1 as well as. And local preference is what? If you see router number one, by default local preference is what? 100 from both of the neighbor, right? 12.2 and 13.3. By default, the local preference will be 100, right? In IBGP, not in the EBGP. Higher is more preferred, right? I'm going to make this guy right now. What I'm going to make R3 as a best. I'm going to make this guy as a 500 local preference, and this guy is a 100, right? So higher will be more preferred. So right now, all R2 is the best just because of the lower router ID. R2 is best just because of the lower router ID, and you have to think according to the perspective of R1. You have to think according to the perspective of R1. What I'm going to do on a router number one, router number three, I'm just going to router number three as the BGP default local preference, right? You can see we can change the LP value from this range. I can make this guy as a 5,000 if you want. I can make this 500 as well as do clear IP BGP strict soft. Can we have a look now on R1? Previously, R2 was the best, R3 just because of what? LP. Higher LP is more preferred. So I just manipulate on a R3. It's going to affect on a router number one as well as. That's the meaning of LP is applicable, right? Local preference is applicable for the complete AS number. So if you want to manipulate the path for the complete AS number that are whatever the routers are present in that complete AS number, you can use the LP value. But if you know manipulate the path only to the router local to the router, you go for the weight. It's totally depend on the requirement. But again, what's the problem is happening in this case? The problem is very simple, right? I'm not able to utilize this link now. I'm only utilizing this link because my all path for this network for the 44.0, everyone is a 13.3 is the next one. So what I can do, router on go on router on 3 and let me remove this person right now. What I'm going to do, I'm going to make this person right. I'm going to make this person for R3 is the best for which route? 4.0.0. And or either we can say that for this guy R3 should be best, and all the remaining routes R2 should be best. All the remaining routes 4.0 and what this 4.0 and whatever the future route is coming. In future, whatever the route will be advertised for all the route, R2 will be best. Again, same thing. I just need to create the policy, right? Same policy I have. Create the each route map over there. Instead of the doing the set weight, I'm going to say the set local preference. I'm going to define over there 5,000, right? I can go for the 20,000 as well as 20 route map for me 20, and I just need to apply ASM 1 to 3. I'm just going to apply towards the 34.3. 4. R3 is going to apply towards my neighbor, right? And it should be Cisco inbound because I'm manipulating the inbound update. Now let's copy this guy. I just need to go on the router number 3, hit enter. Now can we have a look on R1, do so IP BGP and do so IP route BGP. What happened? For this particular 4.0.0, and 172.16.0, right? For this particular route, you have to verify on a router number one because I'm making an effect on router. I apply the command on a router number three, but the user are present on a router number one, right? You see, this is the best just because of LP. For C, this is the best just because of the LP. But for this one, still R2 is the best because of the lower route ID, default behavior, right? This is how we are going to manipulate the in-one update. This is how. So whatever the update that is coming from the internet side, right, in your company, this is my company network, right? This is my company network. So whatever the route that is coming from the internet side in your company, you can manipulate the weight like this. Sorry, you can manipulate the path like this in BGP. It's totally depend on the requirement. If you are going to manipulate the for all the routes, you can simply use the weight or simply use the BGP default local preference. But if you want to manipulate the path for the some particular route, then always you have to go for the policy. Policy means what? You have to go for the ACL and .NET. All clear, guys? Now, same thing. What happened now? Try to understand. We have some route in my company network, right? Of course, you are receiving the route from the ISP. Now you are going to advertise this route to the ISP. This is what? This is a outbound update. So we have seen till this point inbound update, right? As I told you that we have a two types of update. Either it can be inbound or outbound. So we have seen the inbound update. Now we have to go through the outbound update. So for the outbound update, what happened? So this is the picture of inbound, right? For the outbound update, we have a metric and AS. Both are lower depth. So if you see right now, one thing, when R1, right? Let's go on router number one, create some loopback, interface loopback number one, IP address will be three loopbacks, and loopback number three. All good to go, right? Let's advertise this router BGP number one. Okay, I knew that. All perfect, right? Three dots I have advertised. So R1 is advertising all these three dots to whom? R2, right? And R1 will advertise this out to the R3, R2 will advertise this out to the R4, and R3 will advertise this out to the R4. In the case R4 is running with the EBGP, right? As we know that next hop will be changed in the EBGP. That's not a big deal. But which path R4 will make a best? Which path R4 will make a best? In this case, which path R4 will make a best? That is totally depend on the older neighbor. That's my EBGP path activities. We have a EBGP between R4 to R3 and R4 to R4 to R2 and R4 to R3, right? We go for the oldest path. So if you see right now on the R4 router, what happened? Do you all 1 minute? Let me debug all. Can you see? I'm interested in this particular route, right? I'm receiving this particular route from the 24.2. That's my oldest neighbor. And if you see for the 10.0, again 24.2, that's my oldest neighbor. And 100.0, 24.2, that's my oldest neighbor, right? You can run the do show IP route BGP as well as. What I'm going to do right now, I'm manipulating the outbound update, right? I'm still present on a company side. I'm still present on a company side, right? I'm going to manipulate the outbound update. For the outbound update, either you can use the metric value or either you can use the ACE path. So let's go through the ACE path first of all, right? ACE path means what? I'm talking the lower ACE path is more preferred. This one. So right now, what R2 is doing? R2 is advertising this network 1.0, 10.0, and 100.0 with how many A's? A's number 1 to 3. Same thing, R3 is advertising this information 1.0, 10.0, and 100.0 with how many A's path? 1 to 3. Single A's path. What I'm going to do over this guy? So right now, R2 is the best. So whenever this user, right, whenever this user that is present outside of the company, this is my inside, right? So whatever the user that are present in my beyond the company, like a ISP side, internet side, right? Whenever some other person is trying to access of your network, how they are coming? They are coming like this because R2 is the best because of the oldest neighbor, right? So am I able to utilize this thing R3 now? Of course not, right? Because I don't have any path from this side. What I'm going to do, I'm going to make this guy try to understand. I'm going to make. I see that. Hey, let's do one thing for this particular route. Make this guy the best. Right on time. What I'm saying that for this particular, only for this particular, 1.0 will be. So I'm going to manipulate the path for this person, right? Not one. I'm going to say the 1.0 is the best for the R2, not for the 10.0. So for the this person, what is the best? So for this person, this guy will be best. So whenever the user will send any traffic for the ping 1.1.1.1, it will go by the R2. When I say the ping 10 dot 10 dot 10 dot 10 or 100 dot 100 dot 100 dot 100, for this particular person R3 will be best. For this particular person R2 will be best. Simple, right? As simple. So for that thing, what I can do from R2 side, right? From this side R2, I'm for this network 10.0.0.0.0 and 100.0.0. For this particular route, I'm just going to add some dummy ACE number. Extra ACE number from R2 like this 1 to 3, 1 to 3, 1 to 3. And from this side, how many A's I'm advertising? Single. And from this side, how many A's number I'm advertising? 1, 2, 3, 4. How, for which particular route? For this particular route. So what R4 is doing? R4 is doing, hey, for this particular route, this one is the best R3 because I'm getting a single ace number from this side, but I'm getting a multiple ace number from this side. But for this particular route, which one is best? 1 or 0? Oldest number. Single ace one. This is you can achieve, right, by using the ace path manipulation. Hey, it's not like that I'm going to only use the ace number 1, 2, 3. You can use any ace number, but it's not a recommendation because it will create a loop, right? If the same ace number is used by the on some another company, they will not receive the update, right? Because ace path is used to prevent the loop. So if you just go back to the router number 4 now, let's come back to the not router number 4. If you just go back to the router number 2, what I can do right now, I'm just going to create some policy now. Create ACL to match the route. So which route I'm interested? Okay, not 1 1, 10 on now. All done. Step number 2. Read route map. Come on. 1. Then set A's path. Prepend. I'm going to prepend the own H number. 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. I can use the different H number as well as 10. So for this particular route, I'm going to add some dummy H number. From which neighbor and route map. So commit 20 for the remaining route. Otherwise, implicit data will happen. Step number 3, apply. Neighbor, I'm going to say, hey, whenever you're sending the update to the 34.4, 24.4, right? On R2, I'm saying that whenever you send the update to the 24.4, apply this policy. Because we are doing the path manipulation for the odd one update, right? That's why my keyword is out. So now go back to the router node 2 and copy this policy, right? So I'll make this guy a comment right now. So otherwise they will make a error, right? So let's do this guy and copy. Or not. Can we have a look now? That's good, right? So if you go back to the router node 4 and check it, previously I was getting all this update from the 24.2, right? Now, bingo. Can you see the huge number of A's that I'm getting from this side? See the difference is happening. Now for this particular route 1.0.0, who is the best? 24.2 because of the oldest neighbor, right? But for this particular route, what happened? I make this guy as a best 10.0.0, who is the best 34.3 because I'm getting a single H number from this side. R3 is advertising single neighborship, but R2 is advertising the huge number of H number. Can you see? R2. This H number I'm getting from this H number I'm getting from. So I'm going to make this guy as a best from R3. So in this way, if the user will send a, if the internet side user, right, will send any traffic to my internal network for 10.0 or 100.0, R3 will become the best. And if the internet user is sending the any traffic for the 1.0, it will follow by the R2. But it's, again, it's recommendation don't use the any extra H number. So right now I have used the extra H number 10 over there, right? Because this is the public H number. This public H number can be used by the some other companies as well as. So in that case, what happened? That company will never receive this update because of the same H number, because ACE path is also used to prevent the loop. So it's always recommendation whenever you're doing the path manipulation with ACE path, always use the own ACE number that is used by the own company. All good. The same way, let's remove this guys on our R2 router. I'm not interested now. No route map, no accesses. Now everything will become the default. Same way, also you can manipulate the path based on the matrix. Matrix is you can say like that. It's a BGP. MAT stand for I forgot the it's a multi-axis discriminator. Cisco MAT. If you see, the full form is multi-exit discriminator. That's the lowest may is always prefer, right? multi-exit discriminator, right? So it's again that is going to manipulate the inbound update, right? So for that one, I can use the MAT metric as well as. So what I can do, for example, if you see right now on router 4, so do swipe it with BGP. So I'm going to make R3 is the best. Why? Because it is the oldest neighbor, right? And my if you see the swipe BGP, so I have nothing on everything is default right now. So what is the MAT values right now? Zero. Metric is zero right now. Metric is zero. Okay. So what I can do, I'm going to make the same policy. I'm going to make the R2 is the best, right? Not are we right now? What happened? Which one is the best? R3. Yep. R3 is the best right now for all this particular. What I'm going to do, I'm going to make when this user right ping 101, it will go via R2. And when this is a ping, right? So it will go via the R3. So I'm going to make for this particular route, R3 is the best for this particular route, R2 is the best. How do I do that? By default, metric is zero, right? Metric is by default is advertising zero, zero this side. What I'm going to do, I'm just going to manipulate the path. On R3, on router number 3, I'm going to advertise this route 100.0.0.0, where metric is what? 500. R3 is going to advertise this route to the R4 as a 500, and R2 is advertise this route to the R4 is what? 0. So of course, R2 will become the best one, right? For this particular one. And remaining 10.0 and this one, it's already best. So if you see, it's already best right now. Right? Simple commands, right? Just need to go on the policy side. I just need to manipulate this thing issue number. I don't need too much issue out there. Okay, I'll do one thing. I'll create this guy with a new notepad pad so that you can write on the configuration as well. Right? I don't need to have this one. So I'm manipulating the path based on the MED extension one format 100.0.0. I'm going to make R2 as the best. Cisco not a set prepend as a set metric as a 5000 format 20, and now I'm going to apply not R3 right 34.4 Cisco R1. Copy. So now that is bingo. All done. So now if you have a look, R4 good to go and done. So this was our task, right? When the R4 is in the ping 101 more, it will go by the R2, right? And when R4 is in the 10.0.0 and 100.0, it will be for the R3, right? So if you see why, just because of the lower matrix. Because from R3, I'm getting the matrix is 5000. Here I'm done, guys. Here I'm done with your BGP. If you have any questions, you can ask me now.
No, sir.
Clear, everyone?
Yes.
Hey guys, I'll tell you one thing. See, I'm literally telling you, it's a BGP path attributes is a little bit complicated as compared to the normal routing protocol for path manipulation, right? But again, I'm telling you, if you understand this path attributes, it's it's very interesting concept, and 110% they will ask mostly they will ask you the question, hey, which I'm going to use to manipulate the inbound updates. For the inbound update, weight and local preference both are higher preferred, and for the outbound update we are going to use the metric and AS path, both are lower preferred, right? All perfect, right? So hope so this thing is clear to all of you guys, and I'm done for the BGP. I'll